Eric Burgess here. An average salary for a company is $54,200. If the standard deviation is $10,100, find the salaries corresponding to these z-scores. And then they give us some z-scores they want us to find. So the first thing we should do is find the formula that we need. We need a formula that takes in z-scores and spits out x values, right? Because these are the values of the salaries. So we remember the z-score formula to be z is equal to our data point, taking away the average, and then we're splitting it up into units of standard deviations, right? And this is the sample version. They didn't say that this was a population, but you could insinuate that it is because it says an average salary for a company. Like, this is a known fact. So it might be a little more proper to write down x minus mu, the population version, divided by sigma. But here it's a little ambiguous. So this is the one I'd actually probably go with, though, because they're stating it as if it were a fact. There's no difference when you do the problem, but later this will become a significant difference as you begin to get into other areas of stats. So, all right, so we've got this. Let's go ahead, and we need something that has an x equals 2 formula, though. So this is z equals. So to get it to be x equals, I'm going to solve for x. Now, you might just find the formula on your chart or whatever if you have a formula sheet, but I cannot remember it at the moment, so I'm just going to solve for x. So I'm going to multiply by sigma to both sides. This is going to simplify these sigmas, and we're going to be left with z sigma is equal to x minus the mean. And then I want x by itself, so I'm going to add a mean to both sides. And these means will go away. They'll go to 0 because negative mu plus mu is equal to 0. And we're left with the mean plus the z-score times the sigma, the standard deviation, is equal to x. So this is the formula. This is the formula that we need. And you might look on your chart. It might be organized a little differently, right? But it's going to be the same formula. So now what we can do is we can find the values that go with these various things. So for A, we're going to first, let's actually write out what all these are. So we've got a mu, and that's the average. And we're told that the average is 54,200. Then they say z, well, we're going to have different z's. These are all our z scores, right? We're told to these z scores. And then we have our standard deviation, which we are told is $10,000, $10,100. So now we can just plug in and get the various things. So it's going to be 54,200 plus, and then A is 0, so that's going to be 0 for z, times 10,100 is equal to, and this is just 0. So the answer is 54,200 for A. And this is an important thing that you should just realize is if the z-score is 0, then we're talking about the mean. It's just the average, because whatever the standard deviation is going to be multiplied by 0. So that's something significant to understand, is that a z-score of 0 means just the average. All right, let's go for B. Again, we use our formula. So we've got the mean, 54,200 plus, and then we've got our z here, so that's 1 this time, times 10,100. And when we do this, this is just going to be 10,100, and we're going to add it. So we're going to get 64,300. And you can do this in a calculator if you want to check me. But this one will make the 5 go up by 1, and this one will make the 2 go up by 1. And this is dollars. Don't forget your units. And that's it for that one. Now we're going to move on to C. So you see, once you have this formula, you're kind of home free. It's just identifying the formula that you need. So we've got the mean plus, and then we've got the negative 2.5. So you notice that I always put down parentheses when I plug in. And this is to avoid any mistakes with the calculator, any sign errors that could happen. So we're going to do that, and then our standard deviations, 10,100. Now I can't do this one just by looking at it, so we're going to have to pull out the calculator, turn this on, and we're going to do 54,200 plus, or in this case it's going to be positive times a negative, so we're just going to put minus 2.5 parentheses 10,100. So the way I've entered it here, I've kind of optimized it to put it in the calculator, but if you typed it exactly as it appears with the parentheses, with the plus parentheses, minus 2.5 parentheses, this would also totally work. If you use that though, make sure you use the negative sign instead of the minus sign. On these calculators, there's a difference. On the later iterations of this calculator, there's no difference, but these ones, they differentiate between the subtraction and the negative sign. So we're going to hit enter, and we get a value out of 28,950. So if you're 2.5 standard deviations below the average, you're making a lot less money. So and that's something that also you should understand is like 3 standard deviations. A z-score of 3 is really, really big. 2.5 is pretty big. 4 is like crazy. So let's go ahead and do we have a D? Yep, we do. So we've got D, that's going to be 1.7. So we've got 54,200, and then we've got plus, and we were doing it for 1.7 times 10,100, our standard deviation. So we're going to go up 1.7 of these guys, and so we're going to be making above the average in this case. So we're going to have 54,200, and then we're going to have a plus, and we don't need parentheses here for this first one, so I'm going to leave them out, but you can put them if you want, times 10,100, and we're going to close it, and we get 71,370. This is also, I thought for this, a pretty big standard deviation. Like that's a big difference in pay. $10,000, like wow. So people are being paid extremely different amounts at this company. I think that's a pretty big spread. So there you go. That is how you do something like this. So you can derive the formula like I did, and that the benefit of this is you don't have to remember multiple formulas. You can just remember this one, and then you just manipulate it to get whatever you need, which is what I like to do. But if you feel less confident with the algebra, you could always just have a sheet with it on there, and you have to recognize that you're solving for the x's in this case because they want specific salaries, and so those would be data points, and that would correspond to x. And then you realize that these are z-scores, so we're going to be plugging in z-scores, and we'll have to be given an average and a standard deviation, which you pretty much always are with these kinds of problems. If you have any questions about this, feel free to let me know. Subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.